So in today's lesson, we're going to look at atoms and radioactivity. So in terms of the specification, we're looking at radioactivity in particles. We're going to describe the structure of the atom, define the terms of atomic numbers and mass numbers, and also isotopes, state that alpha and beta particles and gamma rays are ionizing radiation, and describe the nature of alpha and beta and gamma rays. Let's get on with this. So in terms of atomic structure, basically the atom consists of protons and neutrons in the nucleus and electrons which orbit the nucleus. And an atom will always have the same number of electrons as it does protons because the atom is electrically neutral. So in terms of atomic and mass number, the atom or atomic number, or even called proton number, is the number of protons in the nucleus, and it defines what the atom is. And the mass number is the number of protons plus the number of neutrons inside the nucleus of an atom. So here we have the example of a lithium atom. So lithium has 3 protons. All atoms of lithium have 3 protons, and it has 4 neutrons. Therefore, the mass number is 7, because 3 plus 4 is 7. And there we have it there. So the proton is in the nucleus along with the neutron, and the electron orbits outside the nucleus. The relative mass of the proton is the same as the neutron, and the electron is very light. It essentially has a relative mass compared to the proton of 0, and a proton is positive, neutron has no charge, and an electron is negatively charged. So in terms of nuclear notations, there are 2 types of nuclear notations that you could be asked to use. You have basically the atom name plus the mass number. It would be, say, carbon-14. Or you would have this nomenclature here where you have the chemical symbol in the middle, the mass number above the chemical symbol, and the proton number of protons below the chemical symbol. So there's 2 possible notations that you could be asked to be able to use. And this brings us to isotopes. So isotopes are atoms which have the same number of protons, but they have different numbers of neutrons. Okay, so even though their proton numbers are the same, their mass numbers are different. So here we have the example of the 3 isotopes of hydrogen. So there is a form of hydrogen which has no neutrons, that's known as hydrogen 1. A form that has 1 neutron, that's known as hydrogen 2 or deuterium, and a form of hydrogen which has 2 neutrons and 1 proton, known as tritium or hydrogen 3, also known as heavy water. Okay, so the note would be the number of the hydrogen, and the mass number of the isotope gives you the actual name of the isotope. Okay, so isotopes are essentially atoms which have the same number of protons, but they have different numbers of neutrons. So atoms can also be ionized. Okay, so that's when an atom loses 1 or more electrons, so they become positive ions. And if an atom gains an electron, it becomes a negative ion. Okay, so when you ionize something, you're making it charged. And you do that by taking or giving electrons to that particular atom. Okay, in the example there, lithium atom is uncharged, number of protons equals number of electrons. You take an electron away, and that becomes positively charged because there's more protons compared to electrons. Okay, so where does it come into radioactivity? Well, the nuclei of some isotopes are unstable, therefore it releases radiation, and this radiation can cause this ionization to adjacent atoms. This is known as radioactivity, and therefore this radiation is known as ionizing radiation because that radiation ionizes. And radioactivity is random, so you don't actually predict which atom is actually going to undergo this nucleus decay or breakdown. So there's 3 types of radiation. There's ionizing radiation, there's alpha, beta, and gamma radiation. Okay, so the alpha particle consists of 2 protons and 2 neutrons, and that is strongly ionizing. That really likes to rip electrons off adjacent atoms. Okay. A beta particle is a high-speed electron. It's moderately ionizing. It's quite good at doing that. And then we have the gamma rays, which are high-frequency electromagnetic waves, which you've already seen in the waves topic. And they are weakly ionizing. And you can see their symbols there, the Greek alpha and beta and gamma symbols. So in terms of their penetrating power, alpha particles are quite slow moving. They're quite heavy, so they don't move that much. They get stopped by basically a few centimeters of air or a piece of paper. Beta particles are high moving, high speed electrons. So about 1 centimeter of aluminium can stop a beta particle. And the gamma particle has very high energy. It moves very quickly, the speed of light, in fact. So it takes several centimeters of lead or about 1 meter of concrete. So they're the most dangerous in a sense because they can travel great distances and penetrate great distances. So in terms of deflecting by magnetic fields, which is a property of these particles, alpha particles are deflected in opposite directions because they obviously have opposite charges. Alphas are positively charged, betas are negatively charged. And due to the fact that alpha particles are a lot heavier, they're basically a nucleus of a helium atom, they are deflected a lot less than beta. Okay, so beta gets deflected quite a lot. And gamma rays aren't affected by magnetic fields because, well, they don't have any charge, so only charged species are deflected in magnetic fields. They just go straight through. And then we have, finally, the deflection in electric fields. So again, alpha and beta particles are deflected, again in opposite directions due to their respective different charges. So alpha particles get attracted, obviously, to a negative electric field, or the negative part of an electric field, and betas get attracted to the positive part of an electric field. And again, you can see due to the mass difference, alpha particles are not deflected as much as beta particles. And gamma particles basically just go straight through because, again, they have no electrical charge. And those are the properties of alpha, beta, and gamma particles.